Alright, so for this one, I'm going to think about the two objects I have here and draw that picture first, and that's going to ultimately help set up my conservation and momentum equation. So I have a 60-kilogram hockey player who is holding a 5-kilogram medicine ball. So that's going to be my before picture. Both of them are at rest. Okay, the hockey player is at rest, and he's holding the ball, so therefore the ball is also at rest. Afterwards, the hockey player is going to throw the ball with a speed of 11 meters per second, and we want to know what the velocity is going to be of our hockey player, okay, the 60-kilogram hockey player. So we can go ahead and set up conservation of momentum here. We know that momentum initial equals momentum final. Our initial momentum, nothing is moving in our system. The player's at rest, the ball's at rest, everything's at rest. So our initial momentum is 0. Afterwards, all right, what has momentum? Well, I'm going to call the hockey player object 1. Object 1 is going to have momentum, as is the ball, which I'll call object 2. Okay, so we can go ahead and plug in what we know about each one. Object 1 is a mass of 60. We're looking for that final velocity after the collision. Object 2 has a mass of 5, and we know it's traveling at a speed of 11 meters per second after the collision. What I can do now is do the math here, so I can say 0 equals 60 v1f plus 55. Okay, bring that 55 over, and I can go ahead and ultimately solve for my initial velocity, or my final velocity for object 1, which is the person, and I get negative 0.92 meters per second. So let's talk for a second about what that means. So the first thing that really jumps out to me is that initial velocity is 0. So in my head, I'm kind of thinking, how is it possible that we have two objects that are moving, yet their final velocity adds to 0? And really what it comes down to is signs, okay? We made this be the positive direction, and therefore that's going to be the negative. So whatever momentum the ball has in the positive direction, the person must have the same momentum in the negative direction, and that ultimately cancels out. And that's really what this equation is simplified to. Okay, we need to have 55 kilogram meters per second of momentum for the person, and therefore the person is moving at 0.92 meters per second. And they're moving in the opposite direction from the ball, so that means that it should be negative. All right, let's go ahead and set up this next one here. We have a 2,100 kilogram barge that's traveling down a river here at a speed of 4.5 meters per second. And what we're ultimately going to do is we're going to have a initially at rest piece of cargo with a mass of 300 kilograms dropped onto this barge. So that's our before picture where that cargo is at rest. For the after picture, okay, we're going to have the 2,100 kilogram barge, plus we're going to have the 300 kilogram object on top of that. And what we're looking for in this case is what is that velocity. So once again, we're going to say momentum initial equals momentum final. Initially, and I'm going to say the barge is object 1 and the mass is, or the cargo is object 2. Initially, the only thing moving is object 1, so I'm going to say M1 V1 initial. And what's moving afterwards? Both are, but they're moving as a system. So what I typically do there is I'm going to add up the masses of each object, okay, and treat it as one object. And we can do that because that object is a system. It's moving together. And that's going to be multiplied by V final. All right, I don't have to distinguish between 1 and 2 here because they're moving together. I can now go ahead and start plugging in some values here. So I know this mass is 2,100 multiplied by our velocity here, which is 4.5, the initial velocity of the barge. Afterwards, we have 2,100 plus 300. All right, combining those two masses again because they're moving as one, is that times VF. And so what we need to do now is actually do our math. So on the left side of the equation here, we get 9,450 is equal to 2,400, okay, combine those masses times the final velocity, and so we find that the final velocity here is going to be equal to 3.94 meters per second.